Okay, here's some simplifying surds. Okay, we'll just go straight to it, no need to explain what surds are. So square root 32, so basically you're going to split 32 into some kind of factors, but there are certain type of factors which are better to choose than others. Let me explain. We can distribute the square root over a factor pair, over a product, but then root 4 is good, that's 2, and then root 8. Then we go again with root 8. Look, so 2 times root 4 root 2 here, and then that's 2 times 2 times root 2, and that is 4 times by root 2. So root 32 can break down to 4 lots of root 2, and that's absolutely great. But when you see all of that work there, compare that now with what if we chose a bit more sensibly. What if we chose 16 and 2 as a factor pair for 32? Then we can distribute again, and we get to the answer a lot quicker. So when you simplify surds, if it's a single surd to simplify, you're trying to break it down into simpler terms, to simpler numbers. And can you notice if you choose one of the numbers and it's a nice square number, it's a good thing. This was a square number here also, the 4, but if you choose the biggest square number that's a factor, that's a very, very good move. Okay, so that's the first one here. Let me just get rid of this and I'll do the others on the same page. Okay, so let's do the same again, root 24. So let's go to the square numbers, 1, 4, 9, 16. So do any of those numbers divide into 24? And you've got it, it's 4. So this is a square root of 4 times 6, which is root 4, times by root 6. I switch to a little dot multiplication sometimes, so that's 2 times by root 6. Alright, let's go for B. Oh, so that was B. Okay, let's go for C now. So C is now just thinking about, if I let root 2 equal to A, the question is 3A minus 2 plus 5A. And I think you'd all be really happy with that as a final answer. It doesn't go any further because I can't add A's to just regular numbers. So the answer is actually 8 root 2 minus 2. And you can then just think about, when I do the question, I'm going to gather the root 2's together. So I'm adding together like terms, 3 root 2's, and then add on 5 more root 2's. And then I'm gathering the like terms which have no roots in. Okay. And then the final one, which I think might be the hardest, this is D. This is 3 times by root 2, but then it's cubed. So it's times by 3 times root 2 again. And it's times by 3 times root 2 again. Now you can do the multiplication in any order. So I'm going to do 3 times 3 times 3, which is 27. And then I'm going to do this root 2 times root 2, which is 2. Then I've got a root 2 just to multiply at the end. So that is 54 root 2. And then I'm going to just do it a slightly different way. Because if I just go up here now, if I have 3 root 2 cubed, I can distribute this exponent over both these numbers because they are a product. So I can distribute over a product. So that would be 3 cubed and then root 2 cubed. And it might be quicker because I can now 3 times 3 times 3 is 27 here. Then root 2 times root 2 is 2 times another root 2. So I might get there a little bit quicker if I distribute. And certainly if it was a power of 4 or a 5, maybe I'd choose this second method over the first method.